Around IT in 256 seconds by Tomasz Nurkiewicz. Episode 15. Mutation Testing.
Imagine I wrote a script that takes your codebase and removes a random line. Fairly simple. Or maybe some more subtle change like replacing plus with minus operator, or switching x and y parameters with each other. Okay, so now my script builds your project. Most of the time it will fail the compilation or test phase. But what if the build succeeds? Well, apparently your test suite is not covering some lines. Okay, but what if my script only removes or alters lines covered by tests? How is it possible that the build still succeeds? Turns out your tests aren't as good as you think. And I just described mutation testing that discovers that. Your code coverage metric doesn't tell the full story. The fact that a given line was executed during the unit testing phase doesn't mean it's thoroughly tested. Maybe you skipped an assertion or forgot an edge case. How can you automatically tell a test is thorough? Well, it's definitely not if random changes to the production code don't trigger failures. Changes known as mutations. Tools that perform mutation testing have a wide range of such defects, like removing lines and expressions, inverting conditions, forcing different return values, changing constants, and so on. If a test suite succeeds with a mutation, we say it survived. Thus, our tests need to be more strict. Otherwise, we assume a developer did a good job. In the end, we get a so-called mutant score, which sounds really cool. This is the number of killed mutations to overall number of mutations. 1 is a perfect score. A good mutation testing framework needs to be quite clever. First of all, it must run code coverage analysis. Based on them, framework chooses precisely which tests are covering which lines. When mutating one function, there is no reason to rerun tests that never touch that function. Secondly, framework must somehow alter our code. This is challenging. Theoretically, the easiest way is to parse the source code and make a few changes here and there. In practice, surprisingly, machine code is much easier to tamper with. Mutation testing can take a lot of time, mainly due to running a test suite repeatedly. Also, you may expect many false positives. Last but not least, it will not help you with code that's not covered. It won't replace writing tests. Moreover, if you religiously practice TDD, mutation testing is of no use. Every feature is tested before written, so it's technically impossible to write untested code. Even if you're not using mutation testing framework on a daily basis, consider being one yourself. What? Well, I've seen tests that were green by accident too many times. For example, an assertion statement was used incorrectly. If you're not sure if your tests are actually testing anything, make a random change to your codebase. Replacing greater than with greater than or equal operator should cause a few tests to fail. Ideally, just one. If suddenly 90% of your tests failed, well, I think you are testing the same thing too many times. If your tests are still green, you have a serious problem. That's it. If you'd like to listen to more episodes, this podcast is available on Apple Podcasts, Spotify, or wherever you get your podcasts. You can also subscribe to the mailing list, link in the show notes, to get transcripts and more extra materials. Also, I sometimes share longer versions of the episodes with more in-depth content that didn't make it to the final version. Thanks for listening. Bye.